Okay, we're back. It's Tech Math 2. We're looking at chapter 11 notes. We're looking at sine waves. We're going to go from 11.3 to 11.5. We're starting back off on page 482. They want to know the phase difference, number 20. They want to know the phase difference of this one that's in black. Red is the regular sine wave, and so they want to know what happened to the black one, meaning it's actually shifted. If you take a look in the book, they've got, like I said, a much better picture than what I can draw. So number 20, it's got 90 degrees. Now, they say to the right. I kind of disagree with how they do this. This is kind of backwards. They're asking, what do I have to shift this black curve to get it to superimpose over the red one? It's not normally how we think about things. So I would say, normally I would say this is 90 degrees left. Here's the normal shift, the normal sine wave is in red. If we picked it up and slid it 90 degrees to the left and dropped it, that's the picture that we have. That's that picture in black. They always ask it in this book, like, what would I have to do to it in order for it to be in phase? So they're asking how to put it back instead of where it actually moved, which I think is sort of backwards, all right? So amplitude is 1.5 on this one. That's always the number just in front of the sign. The phase angle, that's going to be how much it's like shifted. And so if we jump to 28 there, the phase angle on that one is this. This is sort of the shift. That's negative 30 degrees. But instead of like negative 30 degrees, I'd rather you say 30 degrees to the right. That's actually what negative 30 does. It's kind of the opposite of what you would think. You would think, oh, that would shift it left. No, 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 no. Plus shifts it left, minus shifts it right. And so that's 30 degrees to the right. And then to put it into phase, so in order to put it back, like so it's in phase, to like a fundamental curve, we'd have to say 30 degrees to the left would actually put it back in phase. And so that's how they always ask it. This is what actually happened. We pick it up and move it 30 degrees to the right and drop it down. But to put it back in phase, we'd have to take it 30 degrees back to the left. So be careful about that. I think that's a little confusing how the book presents it. So that's what I want to do that. 11.4, we're not going to do anything on that. They're just talking about the same kind of stuff. So let's jump to 11.5. That's harmonics. Sine wave harmonics. And so that just, all harmonics are, they're describing how many cycles happens between 0 and 360. That's the cycles that are often referred to as harmonics. And that's not hard at all to figure out here. Let me show you. So 34, let's look at 34. They have y is equal to 3 sine 5 theta. That 5 means there's actually 5 cycles within that 360 degree period. So 5 of them happen within 360 degrees. And so we could figure out the period then of the cycle by taking 360 and dividing it by 5. That would be 72 degrees. So every 72 degrees, we would start a brand new sine wave. And so there would basically be 5 for the price of 1. You get 5 sine waves, where normally there's only one one in the 360 degree space. And this 3 would be the amplitude. That would bump up the amplitude. For 34, they just want us to put in numbers and plug and chug. So they want theta is 12 degrees, so we just say 3 sine of 5 times 12. And so that's 3 sine 60. And when you do that, that's, what is it, 2.60? All right. And then the other one, they want negative 45 for theta. So that's just plug and chug. You can just literally put 3 sine, and when the parenthesis comes up, go negative 45 times 5, and then hit enter, and that'll give you the 2.12. All right. So let's take a look at how harmonics work then. Let's jump to 42. So number 42 is on page 493. We got y equals 10 sine 4 theta, y equals sine 6 theta, and y equals 1.9 sine 9 theta. And they want to know what degree of harmonic each one of these are. Which is just a fancy way of saying how many cycles happen between 0 and 360. So this is going to be a 4th degree harmonic, or just a 4th harmonic. This one would be a 6th, and this one would be a 9th. And so, oops. So 4th, 6th, and 9th. It's just whatever number is in front of there. That's how many cycles happen in a 360 degree period. So it's going to look all squished down. If I had a 4, this 10, 4, that 10 would pull it way up high, way down low. So instead of going up to 1 and down to negative 1, it would go up to 10 and down to negative 10. That's the amplitude. But this, we'd get 1, 2, 3, 4 of them. 1, 2, 3, 4 of them, and that would be 360 degrees. Where a normal sine wave wouldn't look like that. A normal sine wave, let's go halfway between, would only go up to 1 and down to negative 1. And what's halfway between there? It looks all stretched out, but it's just because I have the 360 like lagging, you know what I mean? So there's 4, that's the 2 differences. The amplitude would go up to 10, and we'd get 4 for the price of 1. There would be 4 of them in there instead. And so that would have 90 degree periods. Like this is 90 degrees, this is 180 degrees, this is 270 degrees, and that's 360 degrees. 90 degree periods, because whatever 360 divided by 4, that's going to be where it repeats itself. All right. All right, 42. Then let's, what if they tell us it's a 4th? Here, let's look at 43. They tell you, give me the equation if it's a 4th harmonic with an amplitude of 0.75. Well, that would be 0.75 sine 4 theta. That's it. They gave you the amplitude and they gave you the harmonic. The second one is a 10th harmonic with an amplitude of 8.3. So that'd just be 8.3 sine 10 theta. All right. So that's just kind of knowing the terminology for those. And that's all of them for 11.3 to 11.5. The next video will be starting with 11.6.